Assalamualaikum students, this is Safabat Khan. Today I will be taking you with some online physics lectures for CIE students, and the topic what I have selected today is wave motion. It's an important topic for CIE students, definitely. They have discussed this topic in grade 10. Now they're appearing here, so they should go with the concept what actually wave motion is. Questions that have been asked in CIE paper is actually, if the concept is clear, then you are able to answer. Otherwise, it's not an easy job to deal with those questions. But let's start with what actually wave is and how it is produced. Whenever I'm checking your copies for whether they are mocks, pre-mocks, or your class test, in past papers you are given a question, define wave motion. And what usually students do, they define wave. The difference between what actually wave and wave motion is. So let's start with what actually wave is and what wave motion is. What actually wave is, how wave is produced. Wave may be defined as a traveling disturbance of the particles of the medium. अगर किसी भी मीडियम में मौजूद particles की traveling में disturbance cause हो जाए, it produces a wave. And what is wave motion? Whenever wave is produced, it carries energy along with it. And the mechanism by which that wave actually carries energy from one place to another is called a wave motion. How many types of waves we have? So it depends upon how those particles actually moves, how those particles actually vibrates. Why I'm using the term vibrate? We have three types of motions. It's translatory, it's circulatory, it's vibratory. Whenever wave is produced, the particles which are forming waves, they actually execute a vibratory motion. And what vibratory motion is? It's to and fro motion about a mean position. What that mean position is. For example, if this is the pendulum, if I left it undisturbed, the position it points is mean position. I drag it to a certain height and release it, it starts swinging. From where it is passing again and again, from this position. It's called a mean position, or we call it a rest position, or we call it an equilibrium position. This to and fro motion, to and fro means left right, about a mean or rest position is called a vibratory motion. And whenever particle forming waves moves, they actually vibrates. So that's why whenever we talk about waves, so we come across vibratory motion. Okay, so what actually wave is? It's a traveling disturbance of the particles of the medium. If you take an example of it, just take a tub of water, place water in it, it's still. Just drop pebble in it. What you will observe, ripples are formed, and they are forming and they are moving outwards. So what is happening? The disturbance is propagating outwards, like this. If you drop a pebble, the disturbance propagates outwards like this. That means they're actually forming what? They're actually forming waves. So what actually wave is? Wave is actually the traveling disturbance of the particles of the medium. And when this disturbance is happening, what these waves are actually doing, they are carrying energy along with them. And the mechanism with which they are carrying energy with them is called what? It's called a wave motion. So let's talk about what actually wave and what wave motion is. So let's write those two definitions. Let's start with the first definition. What is a wave? How can you define a wave? The comprehensive definition for defining wave is, it's a traveling disturbance of the particles of the medium. What actually wave is? It's a traveling disturbance of the particles of the medium. And how can you define a wave motion? So you can define wave motion as, it's simply what? A mechanism. By which energy is transferred from one place to another. These are the two most important definitions. Right? Now, the types of waves. How many types of waves do we have? अभी मैंने आपसे share किया कि when wave is actually produced, the particles executes a vibratory motion. Vibratory motion means they move to and fro about their rest position. How many types of waves? Two. Transverse and longitudinal. What longitudinal waves are and what transverse waves are? Whenever a teacher asks a question from students, what are transverse waves and what are longitudinal? Rather, they should give the definition. They said, sir, light wave is transverse waves and sound waves are longitudinal. Sound waves, they are invisible. Light waves, they are invisible. So how can you explain if sound waves are longitudinal, how they looks like? Light waves are transverse, how they looks like? So, with the help of some practical waves, let's talk about these invisible waves. Transverse waves, light waves actually. Let's take an example. Take a rope, fix it one end with the wall, take another hand in your hand and give a jerk to it. When you give a jerk to it, this type of wave is produced. This type of wave is actually what? A transverse wave. What it consists of? Abhi dekhte hain. Definition dekhte hain, see what the proper definition is. And this is how light waves looks like. Light waves, in short, they are transverse. They do not require medium for their propagation. Light waves को propagate करने के लिए medium नहीं चाहिए होता. If examiner asks you why they do not require medium for their propagation, answer is because they are electromagnetic in nature. So being electromagnetic, they do not require medium. What electromagnetic is? We will discussing it later. Then sound waves. How sound wave looks like? They are invisible. So with the help of some visible waves, let's talk about some sound waves. Take an example of a slinky spring. If you take a string, it has a number of loops or turns in it. When you stretch it and release it, it starts vibrating. How it looks like? From where you stretch it, loops at a distance. And some point, stretch nahi ho. This type of waves produced in string are actually what? Longitudinal waves. Let's define them properly, comprehensively, and how to draw a diagram for these waves. So let's start with how these longitudinal and transverse waves looks like. As I've told you, they execute vibratory motion, and vibratory motion is to and fro motion about a mean position. So let's talk about the transverse waves, how they are produced. So just place the heading, types of waves. The first type of wave we are discussing is transverse wave. How these transverse waves look like? I have told you, transverse waves, जैसे कि rope पे बनती है. So let's take an example. It's a rigid support. For example, it's your wall. It's your rope. Or it's your rest position when traveling disturbance haven't taken place. When you give a jerk to this rope, you get. Before that, what is the motion of the particles of the medium? They are moving like this in the rope, straight. When you give a jerk to the rope, what happens? These particles moves up and down. So when I have made this diagram, so this is the rope and this is called its rest position as well. When I have given a jerk to the rope, these particles travels like this. Whenever wave is produced, always remember, the wave motion is always forward. Whenever wave is produced, wave motion is always forward. And what about the motion of those particles? Those particles are traveling straight, but when that disturbance is caused, these particles starts moving up and down. So, motion of particles, in this case, is up and down. And what about the wave motion? It's always forward. If you compare the motion of particles to the wave motion, what you will find the motion of particles is up and down and the wave motion is forward. That means motion of particles is making an angle of 90 degrees with the wave motion. So how can we define transverse waves? The transverse wave is a type of a wave in which motion of particles is perpendicular to the wave motion. The particles move to and fro about what? A mean position. The straight line is what? The mean or the rest position, right? And whenever traveling disturbance is caused, particle moves up and down, wave is propagated forward. So how can we define transfer wave? It is being asked to define an exam. So transfer wave can be defined as, it's a type of a wave in which motion of particles of a medium is perpendicular to what? The wave motion. Next, transverse waves do not require medium for their propagation. They do not require medium for their propagation, but that medium we can travel precipitately. Why? We can travel without the requirement of the medium because they are electromagnetic in nature. I'm going to make the point-wise discuss today. Number one. So, what happens in transverse waves? Motion of particles is perpendicular to what? To wave motion. Right? And what wave motion is? You all know. Second point, these waves do not require medium for their propagation. For its propagation. Propagation means traveling. Why they do not require medium for the propagation? Because they are electromagnetic in nature. So transverse waves are electromagnetic waves. And the most important characteristic of transverse waves, they consist of crests and troughs. Now what are crests and troughs? We will discuss it later, but for the time being, the high points on the wave are called crests and the low points in the waves are called trough. So this is what actually a concept of transverse wave is. And last but not the least, light waves are transverse waves. Alright? So this is what a concept of transverse wave is. Just repeat quickly. What is wave? It's a traveling disturbance of the particle in the medium. What is wave motion? It's a mechanism with which energy is carried from one point to another. How many types of waves we have? Two. Transverse and longitudinal. Let's talk about transverse waves. How they are formed. This is an example. How can we define them? Okay, transverse waves are types of the waves in which the motion of particle is perpendicular to the wave motion. They do not require medium for the propagation. Why? They are electromagnetic waves. They are electromagnetic in nature. They consist of crests and troughs. This is the characteristic property of transverse waves. What actually crests and troughs are? For the time being, the high points on the wave is crest and the low points on the wave is trough. And last but not least, light waves are transverse waves. Let's talk about a longitudinal wave now. How longitudinal waves looks like. Number two, it's longitudinal wave. So we all know longitudinal wave is actually what? A sound wave. What sound wave is? Sound wave actually requires a medium for its propagation. Sound wave को medium चाहिए होता है. If I give you an example, इस वक्त एक रूम में हम लोग, of course, यहाँ पे medium मौजूद है. It's air. अगर मैं इस रूम को चारों तरफ से बंद कर दूँ, वैक्यूम क्रिएट कर दूँ और सब एयर सक आउट कर दूँ, अब ये नहीं कहना सर आप सांस कैसे लेंगे? सांस ले, for example, assume करने में नहीं, physics सब assumption नहीं है. Assume this, suppose this, let physics say, assume, and then जब मैं इधर वैक्यूम क्रिएट कर देता हूँ, so क्या इस कमरे में अंधेरा हो जाएगा? No. Why? Vacuum means there is no air. अंधेरा क्यों नहीं होगा? Light को medium नहीं चाहिए. Medium है या नहीं? Light will travel, but you won't hear my sound. You only see my lips are moving, but you won't hear a sound. अब हमारे past papers के अंदर जो question है उसके अंदर क्या है? Just take a bell jar. Bell jar के अंदर bell रखें. वो bell भी electric bell ऐसे ही कि उसके अंदर gong और hammer हो कि just hammer जब strike करे against the gong, so आपको आवाज आएगी. But when you create a vacuum in that bell jar, hammer is striking against the gong, but you won't hear a sound because there is no medium. But उसमें dark नहीं हो जाएगा, अंधेरा नहीं हो जाएगा, because light medium नहीं रखती for its traveling, whereas sound needs medium. And sound waves example देखें how sound waves looks like. So if I draw an example, so get a spring template. If I stretch a spring, तो उसके कहीं पे loops compress हो जाएंगे, कहीं पे expand हो जाएंगे. How it looks like. So let's draw an example for that. Achha, and whenever you start drawing a wave, initially there should be a rest position. So this was the rest position of that rope, and when you have given a jerk, that particle starts moving up and down. So you have to be just, this is the rest position of that string. When you have given a jerk, so those like this. Scalar markers, that this is the advantage that I have. Okay. This is how longitudinal waves looks like. This was the motion of the particle when the spring was not stretched. When a spring is stretched, a wave is formed. Whenever a wave is formed, I have told you that wave motion is always in forward direction. So this is what? A wave motion. Now what is happening to the particles? Particles कैसे move कर रहे हैं? In this type of wave, when you are given a jerk, particles starts moving up and down. But in this case, particles starts moving left, right. So what you are observing in this case, that the motion of particles is just right and left. And here the motion of particles is up and down. So if I label it, this is what? The motion of particles. Right? So what you are observing in this example, that the motion of particles is actually parallel to the wave motion, or motion of particle is in the direction of wave motion. And if I draw it, this is the motion of the particle and this is the wave motion. So what you are observing, both are parallel to one another. So if I start defining what actually longitudinal wave is, if motion of particles is parallel or in the direction to wave motion, then wave is called longitudinal wave. Second, transverse waves do not require medium, but longitudinal waves requires medium for its propagation. When they requires a medium for its propagation, why they requires a medium for its propagation? Because they are mechanical in nature. So we may say that longitudinal waves are mechanical waves. So why longitudinal waves are mechanical? Because they requires a medium for its propagation. What transverse waves actually consist of? They consist of crests and troughs. What are crests? These are the high points on the waves. And troughs, low points. And what these transverse waves longitudinal waves actually consist of? They consist of R and C. What this R is actually the rarefactions. And what that C is, it's a compression. So what actually rarefactions and compressions are? So what is crest? High point of the wave. Trough, low point of the wave. Which wave? Transverse wave. What are rarefactions and compressions? Rarefactions they have high energy. In compressions, they have high energy. Rarefactions, they have low energy. Okay, what actually compression and rarefactions are? The rarefactions actually are the regions with low energy, and compressions are regions with high energy. So the last point we can write is they consist of compressions and rarefactions. Right? So now you can easily distinguish what actually crest and trough is and what actually compressions and rarefactions are. And last but not the least, light waves are transverse waves. So here we can write sound waves are longitudinal waves. So this was the initial topic. So just to summarize what we have discussed. We have started with what actually wave is. What is wave? It's a traveling disturbance of the particles of the medium. What is wave motion? It's a mechanism with which the energy is carried by the wave. How many types of waves we have? On the basis of the mode of the vibration, we have two types of waves. Number one, transverse, and second, longitudinal. What transverse waves actually are? It's a type of a wave in which motion of particles is perpendicular to the wave motion. These waves do not require medium for the propagation. Why? They are electromagnetic in nature. The characteristic property of transverse waves is they consist of crests and troughs. An example, light waves are transverse waves. Longitudinal waves. Longitudinal waves, example, they are reduced in a string. So how can we define them? It's a type of a wave in which motion of particles is parallel to wave motion or in the direction of that wave motion. Longitudinal waves, they require a medium for their propagation. They have a mechanical nature. They consist of what? Compressions and rarefactions. What are compressions? These are the regions of high energy, and rarefactions, they are the regions of low energy. And last but not the least, sound waves are longitudinal waves. So this was initial lecture. Just after that, we will be starting with what actually the characteristics of the waves we have. We will be discussing some properties of the waves. There's some basic terms. What is wavelength? What is an amplitude of the wave? What is time period frequency? So let's tune up for that next lecture. So bye for now. Inshallah next lecture हम discuss करेंगे किस तरीके से हम इनकी properties को work करते हैं और some characteristics. And then we proceed towards some past paper questions so that वो आपको help out करें. Allah Hafiz. Take care.